Hey guys, these are our last two lessons, 7.7 and 8.2. Let me make sure. 8.2. In 7.7, we're going to talk about complex numbers, which are a combination of real numbers and imaginary numbers. So I'm going to introduce imaginary numbers, and then we're going to talk about complex numbers. And then our last lecture is going to be on the quadratic formula, which you can use to solve for x if you can't factor a polynomial. Okay. So let's get started. All right, complex numbers are going to be used for even roots of negative numbers, and we write them in the form a plus bi. Okay, the root means radical, right? So the even root, that means something like this, something like this, something like this. The even root of a negative number. So the square root of negative 16, the fourth root of negative 100, maybe something like that. Okay. Usually, when we encounter square roots of negative numbers, we would say there's no solution or not a real number as our answer. That is still true. There are no real solutions of negative square root, the square root of a negative number. However, we can introduce a new set of numbers to find a solution to a negative under a square root, okay? They are called imaginary numbers. Imaginary, when you see I, just think imaginary. An imaginary number will have the letter I behind it. That is called the imaginary unit I. The imaginary unit, written as I, is the number whose square is -1. So if you have a situation where you have a -1 under the radical, you can say that that is an I. Good. The square root of -1 times 5 is I square root of 5. That square root of -1 is I. All right, let's do a few more. The square root of -9. So we know the square root of 9 is 3, right? But we used to say the square root of -9 is no solution or is not a real number. Instead, we can say that that's the square root of -1 times 9, right? Two factors of 9 are -1 and +9. Two factors of -9, I apologize, are -1 and +9. So that can become the square root of -1 becomes I. So that becomes I square root 9. And the square root of 9 is 3. So that is actually 3I. That is why I exist. That was what we use I to do. We use I to simplify a number that is negative under an even radical. If I is equal to the square root of -1, that means that I squared, let's look at this, I is equal to the square root of -1. If I said, what is I squared? If I square this side, I have to square this side. So I squared is, we lose that and lose that, -1. Good. All right, so let's use what we know of I is equal to the square root of -1 to solve or simplify these radical equation expressions. They don't have an equal sign. So the square root of -25 is the square root of 25 times -1, just like we did up here with the 9. The square root of -9, it becomes -1 times 9, all under the radical. You can even separate it out. The square root of 25 times the square root of -1. The square root of 25 is just a 5. The square root of -1 is an I, so it's 5I. Make sure that you are translating it. Never mind, ignore what I just said. All right, here we have the square root of negative 121 and a 5 on the outside. If you remember from previous units, if there's a number on the outside, what you're going to do is you're just going to multiply that 5 by whatever you pull out of the square root of negative 121, okay? Use a different color for clarity. We need the square root of 121, right? Times the square root of negative 1. That becomes I, but what is the square root of 121? 11. 11 times 11 is 121. They are both under the radical, so they come out. Just like 25 is 5 times 5. So that becomes 5, right? 121 is 11 times 11. So negative 121 is, just this part is 11I, right? Because the 121 becomes 11, the negative 1 becomes an I. However, we still have that 5 in front of it, so we're going to take this 5 and multiply it by the 11I. 5 times 11I is going to be 55I. Good. All right, here's another one. Negative square root of negative 121. We kind of know already, right, that the square root of negative 121 is going to be negative 1 times 11 times 11. The 11 and the 11 come out. The negative 1 becomes an I. So it is 11I. These two 11s become that 11. That negative 1 becomes that I, based on that new rule. Good. However, we have, just like we had a 5 in front here, we have a negative in front here. So it's a negative square root of negative 1 times 11 times 11. So it's a negative 11I. Okay. All right, let's do a number that might not come up perfectly. It might only be simplified. It won't equal a whole number. Because if obviously it's a negative, but if I just take the square root of positive 32, I'm not going to get, 32 is not a perfect square. 121 was a perfect square, 25 was a perfect square. Negative 32 is not a perfect square. What do you do in that case? You write it over here, 32 times negative 1, right? That negative 1 is going to become I, so it's no longer under the radical. But how can we factor 32? Is there any perfect square that goes into 32? Does 32, let's start with 2 times 2 is 4, right? 32 divided by 4 is 8. 32 divided by 9 is 3.5. 32 divided by, what's the next one? 16 is 2. Good. So 32 is 16 times 2 under the radical. The I is not under the radical anymore because a negative 1 under the radical becomes an I. The 16 is a perfect square, right? It's 4. The square root of 16 is 4. So that square root of 16 comes out as 4. We're left with a 2 under here times I. I'm going to put the I with the 4 because it's not under the radical. So the final answer for the square root of negative 32 is 4I square root 2. Good. Same here, we have something that's not a perfect square. 24 is not a perfect square, but now we also have a number outside. So remember, with the number outside, we just multiply that by whatever your answer was, okay? 2 times the square root of negative 24. Let's look at 24. Negative 24 becomes positive 24 and negative 1. Negative 1 becomes I. 24, can we divide it by? We can divide it by 4. We can't divide it by 9. Can we divide it by 16? We can't divide it by 16. So, sorry, you couldn't see it. So 24 is just going to be 4 times 6, right? The 4 comes out as a 2. We'll leave the 6 under, times I. So our final answer is 2 times I, because I is not under the radical, times the square root of 6. That's how to change a negative radical to an imaginary number. Now, we know how to multiply and divide radicals, but now let's practice multiplying and dividing negative radicals under even roots and simplifying with I, okay? This is very important, okay? Before you combine a negative times a negative, I know that a negative times a negative is a positive, but we want to change them to, we want to deal with the imaginary unit before we combine them, okay? So the square root of negative 3 is going to simplify to the square root of 3 times negative 1, okay? So negative 3 becomes 3 times negative 1. Negative 5 becomes 5 times negative 1. We're going to deal with the imaginary units, okay? So the square root of 3 times the square root of negative 1 becomes I square root of 3. Okay? Times the square root of 5 times negative 1 becomes I square root of 5. Okay? Now I have dealt with the imaginary term. And what it's going to become is multiply the outside of the radical and then multiply what's under the radical. I times I is I squared. And then just multiply 3 times 5. The square root of 3 times 5 is 15, right? So what we have is I squared square root 15. Are there any perfect squares inside 15? 15 divided by 4? No. 15 divided by 9? No. So we have to leave the square root of 15 as is. However, we know one rule for I. Simplifying with I means that I is equal to or can be replaced with the square root of negative 1, and I squared can be replaced with negative 1, okay? So take that I squared and call it negative 1. Negative 1 square root 15 or negative square root 15. Okay, so final answer to this is that the I times the I is I squared, which becomes a negative 1. So it's, make sure that you understand this. It's not intuitive, right? You should be negative times a negative is just a positive square root of 15, right? Negative 3 times negative 5 is a positive 15. But you need to account for the imaginary term before you multiply the 3 times the 5, okay? So it's actually negative square root of 15 because the negative 1 under the radical becomes I, the negative 1 under the radical becomes I times I becomes I squared, and that becomes a negative 1, so it's a negative of whatever your answer is, okay? All right, next we have the square root of negative 125 over the square root of 5. Let's use this color. Again, just like the square root of negative 3 became the square root of 3 times 1, 3 times negative 1, we're going to call the square root of negative 125 the square root of 125 times negative 1. And under here, we're just going to keep it as the square root of 5. Okay, take out the square root of negative 1, call it I. Okay, so that is now I times the square root of 125 over the square root of 5. Because it's on the top, I'm going to put it out in front. I times 125 over 5. Okay, they're both under an even radical, the radical with an index of 2. So because I've dealt with the I can now put them under the same radical as a fraction. So now I can just put into my calculator 125 divided by 5 is 25. So I'm going to say that that is I square root 25 The square root of 25 is 5, so this my final answer for the square root of negative 125 over the square root of 5 is 5i. Good? Okay. Same here. The square root of negative 96 is going to become the square root of 96 times negative 1 over the square root of positive 3 times negative 1. So those i's come out. Now I have I square root positive 96 over I square root 3. I divided by I, they actually cancel out, right? If you have something that is a common multiple on the top and the bottom, you can cancel it. That is now just the square root of 96 over 3. See if you can divide 96 by 3. You can, and you get the number 32. So that's the square root of 32. See if you can simplify 32 at all, okay? 32 divided by 4. Yes, 32, I know we've done this. 32 divided by 9. No. 32 divided by 16, right? So 32 is 4 square root 2. Good? Because the square root of 32 becomes the square root of 16 times 2. The square root of 16 is 4. So the 2 stays under the radical. That is, yeah, multiplying and dividing. Let's do a few more. We have the square root of negative 5 times the square root of negative 6. So just like up here, we took out the I first, and then we multiplied what was under the radical. So the square root of negative 5 becomes I'm going to skip a step, I square root of 5. The square root of negative 6 becomes I square root of 6. I times I becomes I squared. Under the radical, 5 times 6 becomes 30. I squared becomes a negative 1. 30, is there any number, sorry, that 30, any perfect square that 30 can be divided by? 30 divided by 4? No. 30 divided by 9? No. 30 divided by 16? No. So I'm just going to call that negative square root 30. Good. Okay. Again, we have negative 9 times a negative 1. The square root of negative 9 becomes I square root of 9 times the, excuse me, the square root of negative 1 is just I, right? So I'm just going to automatically change that to I. I times I is I squared. The square root of 9 is 3. I squared becomes a negative 1. Negative 1 times 3 is a negative 3. The square root of 125 times the square root of negative 5. If you can simplify beforehand, that's fine. If not, you could multiply them. No, you can't, sorry. So 125 becomes 25 times 5, right? 25 times 5 becomes 5 square root 5. And you can check that in your calculator. The square root of 125 is the same as 5 times the square root of 5. So the same number. And then over here, we have times negative 5. That means it's 5 times negative 1, which is I square root of 5. Okay? So now we have 5 times I is 5i. And under the radical, we have 5 times 5, which is 25. Well, the square root of 25 is 5. So 5 times I times 5 is just going to be 25i. Good. All right, last one for multiplying and dividing. We're going to take the square root of negative 27 divided by the square root of 3. The square root of negative 27 becomes I square root 27 over square root of 3. Like we did up here, because the I is on top, we're going to put it out in front. So that now becomes I times the square root of 27 over 3. 27 divided by 3. Don't worry about the radical yet. Just simplify under the radical. 27 divided by 3 is 9. So that is now I times the square root of 9. The square root of 9 is 3. So it's I times 3. Just flip it around. It's 3I. That is how to work with just the imaginary unit I. There's another form, or there's a step further we're going to take it in this lesson, and that is using using the unit I, or an imaginary number, to create a complex number. A complex number is a number that can be written in the form a plus bi, where a and b are real numbers. Okay? A is the real part. Okay? A is a real number. Bi is an imaginary number. So when you see something that looks like 8 minus 3i, that's a complex number. 8 is real. Negative 3i is imaginary. And you can do that with all complex numbers. Negative 6 is real. Plus the positive 2i is imaginary. The 6 is real. The 4i is imaginary. The negative 7 is real. The 5i is imaginary. Okay, so it's going to ask you in my math lab, if b equals 0 for a plus bi, that means you have a plus 0 times I. Then what you have is just a, because 0 times anything is 0. A plus 0 is just a, so that's a real number. Real number. If a is 0, then 0 plus b times I is equal to bi, so that's an imaginary number. The first number, or the number without the I, is the real part. The part with an I being multiplied by it at the end is the imaginary part, okay? We're just going to add and subtract the complex numbers, then we're going to multiply the complex numbers. We'll be done, okay? They are called the sum or difference of complex numbers. Remember, sum just means we're adding the complex numbers. Difference means we're subtracting the complex numbers. Here is a formula, but I think it's a bit overcomplicated. All you're doing is, if it's a subtraction, you're distributing that -1, and then you're combining like terms, okay? However, if you want to look at this, if a plus bi and c plus di, we have a real part is the a and the c. You have an imaginary part, bi or di. If a plus bi and c plus di are complex numbers, their sum is, or when we add them, we're going to add the, oops, sorry. Here's our real part. Here's our imaginary part, right? A plus bi plus c plus di, right? Then what we're going to do is we're going to take those two real parts, combine them, and then we're going to put a plus sign, and then we're going to take those two imaginary parts and combine them, and then put an I behind that, or multiply them by I. So basically what this is saying is, take the A and C, combine it, take B and D, combine it, put an I behind it, all right? The difference is A plus BI minus C plus DI. You still have a real and you still have an imaginary part. A plus bi minus c plus di equals a plus bi minus c minus di, right? We distributed that negative, so it's minus c minus di. And then we still combine the A and the C, but we're subtracting them because the C is negative. And then we're still combining the B and the D like we did up here, but we're subtracting the D because it's negative. Or you can just treat that like an X and combine like terms, okay? So that'll be 8 minus 3i. Negative minus a negative 6 becomes a positive 6. Or negative 1 times negative 6 becomes a positive 6. And negative times a positive 2i becomes a negative 2i. And then you're going to combine like terms. The 8 and the 6 are real. The negative 3 and the negative 2 are imaginary. So the 8 plus the 6 becomes 14. And then the negative 3 minus 2 is a negative 5i. So the answer to this is 14 minus 5i. Good. 6 plus 4i minus negative 7 plus 5i. So let's first distribute the negative. 6 plus 4i minus a negative 7 means plus 7. Minus positive 5i is a negative 5i. Good. Now we're just going to combine the like terms, just like this was real. This is imaginary. The 4i and the negative 5i are imaginary. The 6 and the 7 are real. So that is 6 plus 7 is now 15. No, 13. 13. And then 4i minus 5i is just a negative I. I'm going to call that 13 minus I. That's all you're doing when you're adding and subtracting, collecting like terms, but make sure to distribute the negative if you need to. All right, here we have a real number, and then we're going to subtract a complex number from the real number. This is real because there's no imaginary part. This is complex because there's a real part and an imaginary part. So it's 6. Distribute the negative. Minus a positive 8 becomes minus 8. Minus a positive 4 becomes minus 4i. The 6 and the 8, things are the correct color. The 6 and the 8 are real. So 6 minus 8 is a negative 2 minus 4i. Done. Sorry, I wasn't pointing my face towards the microphone at all this whole time. 4 minus 7i plus 2 plus 3i. There is no negative to distribute, so it's just 4 minus 7i, as though it had no parentheses, plus 2 plus 3i. We're going to combine the 4 and the positive 2. That's a 6. And then we have the negative 7 plus 3 is a negative 4i. Good. All right. Here, so that was a complex plus a complex. Here we have a complex minus an imaginary. So this is a real number. This is an imaginary number. When they're together, they're called a complex number. So we have 8 plus 2i minus 4i. So the 8 stays the same because it's the real part. And then plus 2 minus 4 is just a negative 2i for the imaginary part. And you are done. Multiplying now. Multiplying is, you're going to treat it just like we treated this as a variable and we combine like terms. Multiplying complex numbers, you're still going to treat it as a variable when you multiply it. Also, multiply as though they were binomials, right? This is a binomial times a monomial. Then use the relationship. So anytime you get an I squared, make sure you change it to a -1, just like we did here, okay? Here we did 3 times -1 times 5 times -1. That -1 under the radical became an I. That -1 under the radical also became an I. So when we multiplied I times I, we got I squared, and we changed I squared to -1. So we're multiplying complex numbers, but we're not leaving any I squareds. We're converting them to -1. Here we have -8i. We're multiplying it by -7i. Just multiply the -8 times the -7. You get 56. A negative times a negative is a positive. I times I is just I squared, okay? But I squared is -1, so it's now 56 times -1, which is just negative 56. Good. Now we're going to distribute the 5i times the 4 and the 5i times the -7i. 5 times 4 is 20. 5 times a -7 is going to be a -35. I times I is going to be I squared. Okay? 20i remains the same. 20i minus 35 times -1. Okay? Make sure you multiply before you add or subtract, if you could add or subtract. The I squared became a -1. So -35 times a -1 is now a positive 35. So it's 20i plus 35. Ooh, something I forgot to mention about complex numbers. You always want the a in front. You want the real number in front of the imaginary part. So if they're marking you wrong, it might be because you put the real part at the end. And I apologize for not saying that earlier. I forgot to mention it. Should have included it in the notes. All right. 6 minus 3i being multiplied by the quantity -7 plus 4i. We're just going to take the first terms, 6, a positive 6 times a -7, -42. Positive 6 times a positive 4, 24. The 6 and the -7 did not have any i's, so there's no I included in the -42, but the 6 and the 4 have one I, so it'll be positive 24i. Now, -3i times -7. -3 times -7 is positive 21. There's an I with the 3, so I'm going to put an I with the 21. And now we have -3 times a positive 4. A -3, sorry, times a positive 4 is going to be a -12. And then there's an I times an I, so I'm going to call it I squared. 42, -42 plus 24i plus 12i minus 12i squared. Let me rewrite it. -42 plus 24i plus 21i minus 12i squared. Okay, I can combine the imaginary part. Positive 24 plus positive 21. And I will get 45. So that's now -42 plus 45i minus, let's look at this, minus 12, but times I squared. Remember that I squared becomes a -1. So -12 times a -1, that's a real part. So I'll do it in blue. Negative times a negative just becomes a positive. So instead of a -12, it's now a positive 12. -12i squared is the same as a positive 12. -42 plus 45i plus 12. I can now combine -42 and 12. And we get -30 plus 45i. Remember, A in the front, B in the back. Real number in the front, imaginary number in the back. Okay, we're just going to do 3 more examples. We'll be done. Make sure you feel okay about this one specifically. When you have a square root multiplied by a square root. Okay, so when you have a binomial times a binomial, we're just going to FOIL. This is also a binomial times a binomial. Make sure you know what to do when you see it. A quantity squared. -7 plus 6i times -7 plus 6i. Okay. All right. First, the square root of 5 times the square root of 5. Good. If you know how to skip that step, that's fine. Outside, square root of 5 times 3i. Good. All right. Inside, negative 2i times the square root of 5. Sorry, that should be a plus. Negative 2i square root of 5. Out of room. First, outside, inside, last. Negative 2i times a positive 3i. Negative 2 times positive 3 is a negative 6i squared. All right, let me write it again. So we have the square root of 25, right? Because it's the square root of 5 times the square root of 5, plus 3i square root of 5 minus 2i square root of 5 minus 6i squared, just so we can see it a little bit better. Good? Okay. The square root of 25 we know is going to be 5, right? Remember the rule for combining square roots is that if you have the same index and the same radicand, you can just add them, right? So it's 3i minus 2i of square root of 5, or 3i squared of 5 minus 2i squared of 5. Either way you look at it, 3 minus 2 is 1, so I'm just going to call this I squared of 5 minus 6. The I squared becomes a negative 1. So now that's 5 plus I squared of 5. Negative 6 times a negative 1 is plus 6. 5 and 6 can be combined together because they are the real numbers. 5 and 6 are 11. 11 plus I squared of 5. Notice that the square root of 5 times itself just becomes 5. The square root and the square get rid of each other. The square root of 5 times the square root of 5 is the same as the square root of 5 squared. And we know that the square root gets rid of the squared. And it's just whatever you had. Okay? I'm going to do the negative 7 plus 6i down here. Negative 7 plus 6i times negative 7 plus 6i. Same FOIL. Negative 7 times a negative 7 is going to be a positive 49. Negative 7 times a positive 6 is going to be a negative 42i. So that I. Positive 6 times a negative 7i is also going to be a negative 42i. And then positive 6 times positive 6 is going to be 36. There were two i's, so I'm going to call it I squared. Okay, 49. Now we have negative 42i minus 42i. Negative 42 minus 42 is negative 84. Plus 36. Remember, anytime you see an I squared, you should call it a negative 1. Replace it with a negative 1. So now that's 49 minus 84i minus 36, right? 49 minus 36 is 13 minus 84i. Okay. All right. One more and then we are done. Let's look at 4 plus 3i times 4 minus 3i. So it's a little bit like this one, except one of the signs changes. You're multiplying 4 and 3i times itself, but in one case, we're adding them together, and in the other case, we're subtracting them together. Think about what this means. When we were adding them both, when we were adding two negatives, we got a really big negative in the middle. But now we have one positive and one negative. Think about what that might mean. First, 4 times 4 is 16. 4 times negative 3i is a negative 12i. Positive 3 times positive 4 is a positive 12i. of that I. Sorry, I didn't say that. And then 3 times a negative 3i is a negative 9i squared. Okay. 16, this is what happens. Negative 12 and a positive 12. They cancel each other out, and we just have 16 minus 9i squared. 16 minus 9. Remember, anytime you see I squared, it's a negative 1. So it's 16 plus 9, because negative 9 times a negative 1 is a positive 9. 16 and 9 together make 25. And that should be enough. Yeah, that should be all you need to know about complex numbers. Thank you guys so much.